I heard you. I was just trying to get my different microphones to work, but it didn't work the way I wanted. So we'll just have to. Oh, hello. There we go. All right. So you said the second to last one. It was the one about rear view mirrors. Okay. I can see one that's similar. Let me see if this is the right one. So you had a windshield. And on mine, this is 2x centimeters, and this is 3x squared centimeters. And then it gave you the side views as 4x by 3x. And again, 4x by 3x. Does this look similar? And then it asked you for area of the rear view. That would be this guy. So in order to find the area of the rear view, we would just do the length times the width, which is 6x cubed. Part B, nope, area is length times width. The next one should be, yeah, the next one should be 4x times 3x, and then times, or times 2, because we're doubling it. Yep, and then the last one you can add them, because that's the total of all. But it does say to express in factored form. So that would be, let's see, we'd have 6x to the third plus a 24x squared. And what could we factor out of those two terms? It's all right. Yep, you go ahead. Mute your mic. Hold on. I'm going to mute him for a second. Okay. All right, great. Con, did you have anything from the homework? Okay, no, that's fine. It's fine, you got some time. All right, so then today we're going to start 6.2. And we're working on factoring trinomials of the form ax squared plus bx plus c when our a is equal to 1. Okay. All right. I need you to remember what we did with x plus 3 times x minus 5. To multiply this out, we did x times x and then we added to that x times negative 5. Plus 3 times the x plus 3 times a negative 5. This was x squared plus a minus 5x plus a 3x plus a negative 15, or x squared minus 2x minus 15. This is what we're talking about when we refer to a trinomial of the form ax squared plus bx plus c. Whoops, I didn't spell that right. Where a is equal to 1. Because there is a 1 there that we don't usually write. Our goal today is to take x squared minus 2x minus 15 and get it back to x plus 3, x minus 5. The factors. Okay. So do y'all understand what the goal is for today then? Okay. All right. So I'm going to try it with a couple of them and let's see how she goes for you. All right. Will that work? That work. So we're going to start with 1. Let's look at an x squared plus 7x plus 6. Here's the question we have to ask ourselves. What two numbers multiply to give us 6 and add to give us 7? This last term was always the multiplication of two numbers. And this coefficient we always got by adding the two numbers. So what two numbers do we know that will multiply to give us 6 and add to give us 7? Uh, 7 and 1 would add to give us 8. Yep. So 6 is the one we're looking for. If we did 6 and a 1, 6 times 1 is 6, and 6 plus 1 is 7. So what we're going to do is deconstruct this middle term into the two that we're adding together. So I'm going to rewrite this as x squared plus 6x plus 1x, and then I'm going to bring down the plus 6. Now that we have 4 terms, I can use the factoring by grouping that we did yesterday. If I just look at the first 2 terms, I have x squared plus 6x. I can pull an x out of both of those, leaving me with x plus 6. With the second 2 terms, there's nothing I can pull out of both. So I'm going to pull out just a 1. And that's going to leave me with x plus 6. Now I have x plus 6 in both. And as I said yesterday, I pull that out front, leaving me an x plus 1 as my second factor. And there we have it. I've taken my, I'm sorry? Because those are the 2 coefficients that would multiply to give me 6, but add to give me the 7. Here, let's. Yep. This is the 6 plus 1 right here. And that's how we got the 7. keep in mind, Ku, you can always do a quick first. If I multiply the first ones, I get an x squared. If I multiply the outsides, I get a 1x. If I multiply the insides, I get a 6x. And if I multiply the last, I get a 6. Or x squared plus 7x plus 6. You see how I get what I started with? Yeah. So you can always check it. And some people get really good at it very quickly. All right, let's try this one. X squared plus 5x plus 6. Probably. Okay, this is a very similar trinomial to the first one, but we're going to get different factors. Because in this case, we want the two numbers that multiply to give 6, but add to give 5. So what two numbers can you multiply to get a 6, but when you add them, you get a 5? Summer, I think you said it already. What do you think it is, Summer? 3 plus 2 is 5. And 3 times 2 is 6. So that means I'm going to deconstruct this middle term. And I'm going to write it as x squared plus 3x plus 2x plus 6. If I look at the first two terms, I can take out an x, and I'm left with x plus 3. If I look at the second two terms, I can pull out a 2, and I'm left with x plus 3. This x plus 3 is now in both. I will pull it out front. So I have an x plus 3, x plus 2. All right, Ryan, you doing all right? Are you back? All right. Okay, there are lots of examples in here, so. All right, let's try this one. Stomach, knock it off. All right. All right, what about an x squared minus 7x plus 12? We want to multiply to a 12, but add to negative 7. If I do minus 4 plus a minus 3, that is indeed a negative 7. And if I do minus 4 times a minus 3, that is indeed positive 12. So I'm going to take this middle term minus 7x and deconstruct it so that we have an x squared minus 4x minus 3x, sorry, I didn't want a 7 there, plus 12. We'll use factoring by grouping as we did from yesterday. We can take an x out, x minus 4. From my second 2, I can take out a minus 3, x minus 4. X minus 4 is now in both terms. I pull that out front. And there we go. My factors are x minus 4, x minus 3. Nope. No, the last number gives us our clues as to what the deconstruction has to be, but the last number itself is not deconstructed. It's the x term or the middle term that's deconstructed. Now, I'm assuming, Kong, that these are in order, right? That they did. Correct. If it's not in descending order, you would rearrange it to descending order and then go from there. So that is something we sometimes need to watch out for. Oops. All right, so here are two that are essentially the same. We've got an x squared minus 3x minus 10, and we've got an x squared plus 3x minus 10. So in the first one, what two numbers will multiply to give us a negative 10, but when they add them, we get a negative 3? So now when I look at the first two, I'm able to pull an x out, leaving an x minus 5. And when I look at the second two, I'm able to pull a positive 2 out, leaving an x minus 5. So my factors are x minus 5, x plus 2. However, let's take a look at the second example. In the second example here, we have an x squared plus 3x minus 10. So what two factors of a negative 10 will add to give you a positive 3? There you go. Yep, the other way around. And it's important to note that this will change our answer. On the second one, I can pull out a negative 2. So that we've got an x plus 5, x minus 2. That the different signs matter. They will give you different answers. X minus 5, x plus 2 versus x plus 5, x minus 2. That these are, in fact, different answers. All right, there are some patterns here, and I'm curious as to whether or not you can see them. All right, so if you have ax squared plus bx plus c, and c is positive, what does that tell you? In other words, it's got to be an x plus something, or it could be x minus something, x minus something. But those signs, positive with a positive, negative with a negative, have to be the same. Because the only way you're going to get a plus c there is if you're multiplying a positive by a positive or a negative by a negative. What if you've got this same idea, but this isn't a plus c, that's a minus c? Let's say c is negative. Then this side. Go ahead. Correct. If that's the case, then the signs on the factors must be different. In other words, we'd have an x plus a number, x minus a number. Or they could be swapped around. We could have x minus some number and then x plus a number. Because the only way we're going to get a negative c is if we multiply a positive by a negative. Furthermore, Summer, was that you? In this case, furthermore, if your b is positive, then the larger factor must also be positive. And if b is negative, And the larger of the factors must be negative. This bit? Okay. Let me try it with an example, all right? All right. If we had to factor something like x squared plus 7x minus 18. Because this is a minus 18, we know that one of these must be a positive and one of them must be a negative. So what two numbers multiply to give you an 18, but when you add them, you get a positive 7? Good. It's a 9 and a 2 to get an 18. And because this is a positive 7, I know the larger factor must be positive and the smaller factor must be negative. That's what I mean by that B value, right? My B is 7. And because that's a positive number, the factor of the two factors, the larger factor has to be positive. I'm sorry, Summer? No, no. But I don't require people to come to the Collaborate sessions. With everything that's going on, a lot of people have had to switch their work schedule around, or they're in a house with several other people now. So the videos are posted on Blackboard, on Collaborate, and they're also on my YouTube page. So people have been, the few people, we only have like 6 or 7 people regularly in this class. So half of you coming on any given day is pretty good. And everybody who was there that last week before we closed campus is still participating in class. So that's working out for us. All right. So let's try a couple more here. Now, not all of them are going to be just numbers. Let's look at, can you factor an s squared plus 4st minus 12t squared? Good, good, good. So this looks a lot harder, but it's really not. We want the numbers of negative 12 that when we add them, we will get a positive 4. So what two numbers, when we multiply them, will we get a negative 12, but when we add them, we'll get a positive 4. And we'll keep the ST that's there. And then looking at the first two, we can factor out an S. And we're left with S plus 6t. Looking at the second grouping, we can pull out a negative 2t. And we're left with S plus 6t. And we have our factors. Oh, for the B part? Okay. Two different signs. Right. Well, it doesn't have to be the larger factor will be positive. It's not necessarily the first one. I guess I maybe have a habit of writing it first, but it doesn't necessarily have to be the first one. It's just that the larger number will have to be positive. Okay. All right. Mm-hmm. Yeah. Well, we haven't done all the examples yet. There's a couple of things we need to touch on. Okay. All right. So you've brought it up, so we will talk about it. So what happens if you have, let's say, an m squared plus a 3m plus a 5? So what two numbers will multiply to give you 5, but add to give you 3? Can you think of any? Right. There's no combo that will work. So this is when we say it's prime. Okay. Now, I don't know that you're going to get a lot of these right off the bat, but you will get some. There are some in your homework. So watch out for them. But essentially, you can't factor everything. Not everything is factorable. We'll learn some alternate methods a little bit later on, but in the chapter. and in chapter 9. But yeah, not everything is factorable. So when it's not factorable, we call it prime. Right? Okay. The other piece in this chapter is factoring completely. That's a 3. So here we have a 2x to the 4th plus a 26x to the 3rd plus an 80x squared. You can take a 2x squared out of each. And if I take out a 2x squared, then I'm left with x squared plus 13x plus 40. Now we can see if we can deconstruct what's in the parentheses. So, what two numbers will add to give us 40? I'm sorry, will multiply to give us 40, but add to give us 13. 10 times 3 is 30, not 40. There you go. So this 2x squared comes down on the outside. We leave it there. Then this becomes an x squared plus 8x plus 5x plus 40. I can pull an x out, leaving me an x plus 8. And then I can pull a 5 out, leaving an x plus 8. The x plus 8 I pull first, and then an x plus 5. Yep, that's how I. It's only on what? I mean, nah, it could kind of sneak in anywhere. But factor completely, if it says factor completely, that is a huge clue that you're probably going to have to take something out first, right? You want to try a couple more like this? Yeah. What do I got for time? I got 10-ish minutes. Okay. So yeah, sometimes it may just say factor. And then it might have something like a 4m to the 5th plus 8m to the fourth minus 32m cubed. So if you see that, like, what's a clue that you might have to take something out first? The 4 is a clue, but only for today. Tomorrow, the 4 probably won't be a clue. I would say probably a large clue is the fact that this is not a constant term, right? It's not a constant term. Like if you look at like the first 5 examples we did on this, right? You see how it always ended in just a number? Yeah. But this guy ends with an m cubed. So that's a good clue that I can pull something out of all of this. It's not 100%, but it's a good clue. Then I would look at the coefficients. Can I take a 4 out of everything? Well, it's not always a clue that you can pull a 4 out of everything, or that you've got a leading coefficient here. But it is sometimes. It's worth a check if you've got a 4 in front. It's worth a check. Will 4 come out of everything here? Yeah, 4 will come out of 4, it'll come out of 8, it'll come out of 32. I can also pull out an m to the third. Yep. That's going to leave me with m squared plus 2m minus 8. So what about a negative 8? What 2 numbers will multiply to give me a negative 8, but when I add them, I get a positive 2. Good, guys. Kind of all at the same time then. 4m cubed. Oops, let me do this. So it's going to be an m squared plus 4m minus 2m minus 8. m plus 4 minus 2m plus 4. And so in fully factored form, I have 4m cubed, m plus 4, m minus 2. Yeah. Right. I think I understand what you're saying, Ryan. So, yes, when you first look at this and you see an m to the 5th power, everything we've been doing thus far, we would need an m squared. So if this is m to the fifth, that's too big. I need an m squared. So maybe I need to check and see if I can reduce this by pulling out an m to the third. Like m to the fifth is too big a power to factor based on what we were doing in this section. So in that manner, yes, that could serve as a clue. Okay. All right. Oh, there's my alarm for class being over.